So let's just recap what we just discovered. We just discovered that sine A is equivalent to the cosine of B, right? And it goes both ways, right? Cosine B is equal to sine of A. We realized that tangent of A is equal to the cotangent of B, and it goes both ways. We learned that the secant of A is equal to the cosecant of B, and again, it goes both ways. Hey, this is not a coincidence. These are called cofunctions. So sine and cosine are cofunctions. Tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. Now let's go back to our do now diagram. Now remember, trig could only be used on what kind of triangle? A right triangle. So we always have a right angle. Since we always have a right angle, what's the relationship between the other two angles always? They're what? Who said something? I don't know. No, they're not always congruent, right? This could be 60-30. They don't have to be congruent. But they do have to add up to 90. What do we call angles that add up to 90? Think geometry.
Complementary.
Good. They're complements. All right. Anytime we have a right angle, the acute angle, a right triangle, the acute angles are always complements. All right. So cofunctions of complements are always equal. Let's write this out. Cofunctions of complements are always equal. So an example we said is the sine of A, angle A, is equal to the cosine of angle B. But remember, angle A plus angle B has to equal what? 90. So what can I say? I can say the sine of angle A is equal to the cosine of 90 minus angle A. Wouldn't that tell me what angle B is? 90 minus angle A? And this holds true for all of the acute angles in a triangle. All right, let's do some sample problems. All right, I want us to write in terms of its cofunction. Okay, let's just quick recap. What are the cofunctions? Sine and what are cofunctions? Cosine. Tangent and what? Cotangent. Secant and cosecant. These are the cofunctions. All right, so if I have sine of 50 degrees, and I want to write that in terms of my cofunction. Well, the cofunction of sine is cosine, so we're going to start with cosine. And isn't that going to be of the complement of 50 degrees? So what am I going to do? 90 minus 50. So sine of 50 degrees will equal cosine of 40 degrees. You guys try this one. If I have the secant of 83 degrees, I want you to write this in terms of its cofunction. Okay, what should we have done? Well, first we have to identify the cofunction for secant. What's the cofunction for secant? Cosecant. And then it's going to be of the complement of 83, which is 90 minus 83. So we get cosecant of 7 degrees. You got it. All right, let's say I have the tangent of theta minus 10 degrees. And I want to write this in terms of its cofunction. Well, its cofunction will be cotangent, but now I need the complement of my tangent angle. Well, the complement is going to be 90 minus the full quantity of theta minus 10. Why did I put that quantity of theta minus 10 in parentheses? What do I have to do? We have to distribute in that minus. So in terms of its cofunction, it's going to be cotangent of 90 minus theta minus 10. Plus 10. Can I simplify that? I sure can. It's going to be the cotangent of 100 minus theta. Degrees. So here I want us to find the value of theta. And I'm going to have the sine of 2 times theta plus 4 is equal to the cosine of 3 times theta minus 9. So here we're saying these two values are equivalent. One sine and one's cosine. What do we call them? The relationship between sine and cosine, they are cofunctions. And the cofunctions are equal as long as their angles are what? What's the relationship between their angles? Complements. Good. So that means that 2 theta plus 4 plus 3 theta minus 9 has to equal 90 because those two angles are complements. So I'm going to combine my like terms, and I get 5 theta minus 5 equals 90. And we solve. 5 theta equals 95, so theta equals 19 degrees.
You just leave that or we have to like put it into like this?
Nope, it just said find the value of theta. We found the value of theta. We're done. Okay, this next part, it's pretty silly. I don't really care for it, but I'll still have to show you. So we're going to say, is the statement true or false? And I'll show you how to figure it out. Yep. So the sine of 21 degrees is greater than the sine of 18 degrees. Now, just because the angle's bigger doesn't necessarily mean that the sine of it or the cosine or whatever value of it is necessarily bigger. It's all going to be different. So what I want us to do is I want us to use the unit circle. Do we agree that both 21 and 18 are both in quadrant 1? All right, so I'm using my unit circle. My circle skills are horrible. Okay, so now if we have the sine of 21 versus the sine of 18, do we agree the actual angle for 21 is bigger than the actual angle for 18? So for 21, let's say the angle was like this. This is my 21 degree angle. I'm going to drop down a right triangle. Here's 21. Now I have to go to the rim because I'm using the unit circle. So because we're using the unit circle, do we agree the radius is always 1 in the unit circle? Now for the 18 degree angle, it's a different color, it's going to be shorter, right? It's going to be a smaller angle. So it's going to be shorter, but sort of a little bit extended in the x direction. So this pink one is our 18 degree angle. Okay, so now we are trying to compare the sine of 21 with the sine of 18. And no matter what, when we're dealing with sine, it's y over r. Do we agree? But for both of them, what is my r, no matter what? 1. So our denominators stay the same. So all we're doing now is comparing our y's. Well, for the I wrote 20 degrees, same thing. For the 21 degree angle, isn't my y longer than my 18 degree angle? So since y1 is greater than y2, that means the sine of 21 is greater than the sine of 18. So is it true or false? It is true. Let me show you one that doesn't hold true. Matisse, you have both AirPods in. It's like insulting to have one, but to have two. Let's take them both out. Yeah.
I don't really get how you like decide to put one further out.
One for their R?
Like out.
Out?
Like
What do you mean? What do you mean out?
like the 18 is like
because it's a bigger angle.
So 21 is a bigger angle than 18, so 21 is going to physically be a bigger angle than 18. So I made 18 smaller and 21 bigger. But their radius, because we're using it in the unit circle, both have to be the same. So we both have to, for both of them, we have to go to the edge of the circle. Did that answer your question or not? Yeah? Okay, let's do another one. Cosine of 49 is less than the cosine of 56. So once again, we're going to use our unit circle.
Will the
Okay. Hey, again, I'm going to exaggerate this. We know 56 is bigger than 49, right? So 56 will be a larger extension. Here's my 56-degree angle. Drop it down, make a right triangle. But then when I go to make my 49-degree angle, it's going to be smaller. And then I'll drop it down over there. So now this whole blue one is, let's call this X1 for 49. And this whole green one we'll call X2 for the 56. Does everybody see the two I'm looking at? So now for cosine of any angle, it's X over R. But because we're in the unit circle, R is always 1. So really all we're comparing are the X's. So cosine of 49 is X1 compared to the cosine of 56, which we said was X2. Which one is bigger, X1 or X2? X1 is bigger, which means cosine of 49 is greater than the cosine of 56. So was the statement true or false? It was false. All right, let's have you try one on your own, and then we will call it a day. You might need me to do this one with you. Let's see. Let's see how you do on your own, and then we'll go over it. Actually, guys, you can't do this on your own. We need to change them into the same. So secant and cosecant, aren't they cofunctions? So what I'm going to do is I'm going to change secant into cosecant. Well, what's cosecant? If it's secant of 40, then it's cosecant of 50. So you have to change them into the same function. Even with this, it's still a little bit tricky.
Wait, how'd you get the idea?
Secant and cosecant are cofunctions, which means their angles are complements. Who wants more time to try to figure it out on their own? Okay.
it false?
Do you want me to say? Does everybody want me to say?
It's true.
How many people said it's false? How many people said it's true? It is false. It is false. Let's talk about why. So now cosecant of any angle is r over y, right? It's the reciprocal of sine. So now when we go to use the unit circle here to get a visual, we know 50 is bigger, so I'm exaggerating this. So this is my y1, and 48 is smaller, again exaggerating it. It's not half of it, but just for the purpose, this is my y2. So the green is y1, the purplish pink color is y2. But now what we're comparing is the radius over y. Well, the radius is always 1 since we're in the unit circle. So we're 1 over y1 compared to 1 over y2. Now, do we agree that y1 is bigger than y2? But think about it. Let's say y1 was 10 and y2 was 2. Which is bigger, 1/10 or a half? A half is bigger than 1/10. So when you have the bigger denominator, that is actually the smaller number, right? So in this scenario, even though y1 is bigger than y2, 1 over y1 is smaller than 1 over y2. So this is false. Okay, we're done for today.